Organic analysis, how to oxidize alcohols using acidified potassium dichromate 6. Add 10 drops of alcohol to 2 cm cubed acidified potassium dichromate solution in a test tube. Warm the mixture gently in a hot water bath. Watch for color change. If it's a primary alcohol, orange solution slowly turns green as aldehyde forms. Secondary alcohols, orange solution slowly turns green as a ketone forms. Tertiary, nothing happens. Color change, why does it happen? Color change is orange dichromate 6 iron Cr2O72 minus being reduced to a green chromium 3 iron Cr3 plus. So, oxidizing alcohols using acidified potassium dichromate 6, add 10 drops of alcohol to 2 cm cubed acidified potassium dichromate solution. Warm mixture gently in hot water bath. Watch for color change. What's the problem with this? Both primary and secondary alcohols, orange solution slowly turns green. So how am I going to distinguish between this? There we go. So how to distinguish between primary and secondary alcohols? You need to add excess alcohol to 2 cm cubed acidified potassium dichromate solution in a round bottomed flask. That's very important. Add excess alcohol to 2 cm cubed acidified potassium dichromate solution in a round bottom flask. Set up flask as part of the distillation apparatus. Gently heat the flask, and alcohol will be oxidized and the product distilled off immediately so we can collect it. Gently heat the flask, alcohol oxidized, and product distilled immediately so we can collect it. Heat column mixture. No, that's the mixture. That's the fractionating column. Thermometer, your condenser, and then this goes to the container to collect liquid. Using Fehling/Benedict solution to distinguish between aldehyde and ketone. Add 2 cm cubed of Fehling/Benedict solution to a test tube, and it should be a clear blue solution. Add 5 drops of aldehyde/ketone to the test tube. Put test tube in a hot water bath and warm for a few minutes. Aldehyde blue solution gives a brick red precipitate. Ketone, nothing happens. Making tolerance reagent, put 2 cm cubed of 0.10 moles per d minus cube of silver nitrate solution in test tube. Add few drops of dilute sodium hydroxide solution, a light brown precipitate forms. Add drops of dilute ammonia solution until the brown precipitate dissolves completely. How to use tolerance reagent to distinguish between aldehyde and ketone. Place test tube in a hot water bath. Add 10 drops of aldehyde/ketone. Aldehyde silver mirror forms on the walls of test tube. We get silver mirror. Aldehyde, because aldehyde reduces the Ag plus ions to Ag atoms, silver atoms. Ketone, nothing happens. Using bromine water to test for alkenes, add 2 cm cubed of solution you want to test to a test tube. Add 2 cm cubed bromine water to a test tube. Shake test tube. Alkene solution decolorizes, goes from orange to colorless. Not an alkene, nothing happens. Using sodium carbonate to test for carboxylic acid, add 2 cm cubed of solution you want to a test tube. Add 1 small spatula of solid sodium carbonate, or add 2 cm cubed of sodium carbonate solution. If solution begins to fizz, bubble the gas it produces through some lime water in a second test tube. Carboxylic acid solution fizzes. Carbon dioxide gas produced turns lime water cloudy. If it's not carboxylic acid, nothing will happen. High resolution mass spectrometers measure atomic and molecular masses extremely accurately to several different decimal places. And the key fact about high resolution mass spectrometers or high resolution mass spectrometry is that it's useful for identifying compounds that appear to have the same MR when rounded to the nearest whole number. Like you could have an MR 78.89 round to the whole number 79, or 78.82 whole number 79, but it's slightly different, isn't it? So that's why it's useful to identify compounds that appear to have the same MR when rounded to the nearest whole number. Infrared spectrometry, beam of infrared radiation passed through a sample of a chemical. Infrared radiation absorbed by the covalent bonds in molecules, increasing vibrational energy. State 2 key facts about bonds. Bonds between different atoms absorb different frequencies of infrared radiation. Bonds in different places in a molecule absorb different frequencies. Bonds between different atoms absorb different frequencies of infrared radiation. Bonds in different places in a molecule absorb different frequencies. Infrared spectrometer produces a graph showing what frequencies of radiation molecules are absorbing. Therefore, we can identify functional groups in a molecule. Fingerprint region between 500 centimeters to power minus 1 and 1500 centimeters to power minus 1. Peaks show you where the radiation is being absorbed. Peaks show you where the radiation is being absorbed. The peaks point downwards in infrared spectra. Infrared spectroscopy used to find out the purity of compound and identify impurities. Impurities produce extra peaks in fingerprint region. And I forgot to go for this key point. Use a sodium carbonate test for carboxylic acid. This test gives a positive result with any acid. Therefore, we can only use it to distinguish between organic compounds when you know one of them is carboxylic acid. Test gives a positive result with any acid, therefore can only use it to distinguish between organic compounds when you know one of them is carboxylic acid. Greenhouse effect: when molecules of the greenhouse gases, carbon dioxide, water vapor, etc., molecules of greenhouse gases in atmosphere absorb infrared radiation, then re-emit some to the earth, keeping us warm. More heat trapped, earth becomes warmer, and this is global warming.